All right. I think we're about to start. We're about to start. Are you ready? Are you ready? Please help us and share the link so that others can join. Help us and share the link so that others can join. Help us and share the link so that others can join. Help us and share the link so that others can join. Help us and share the link. Help us and share the link so that others can join. Tonight, we are going to treat a lot of things that will make you happy in organic chemistry. Help us and share the link to your class page, class group, to your friends, and those you want to learn chemistry. Oh God. It's that time of the day when we are going to make learning easy and fun. That's the target tonight. To make learning easy and fun. The target tonight is to make learning easy and fun. Welcome on board. This is the Oracle on the line. And tonight, you will experience another dimension of learning with me. We haven't reached up to 100 users yet. Help us and share the link. Once we hit 100 users, we kick it off. Let's do the magic tonight. Irrespective of the country you are watching from, help us and share the link. All right. Tonight, we're going to pick a very important topic in organic chemistry. We're going to take every part of it, from the introduction to the IUPAC nomenclature, to the source, the reactions, the properties, and so on. I will advise you to stay with us to the end because we're going to solve some questions and we're going to brainstorm so that at the end of the day, you can beat your chest and say, I know this topic to the core. Can we start now? Can we start? Can we start? If you want us to start, please type let's go so that we can start. If you want us to start, just type let's go so that we can start. If you want us to start, just type let's go so that we can start. All right, let's do it one more time. Let's do it tonight. Okay. I don't know who is trying to do magic tonight. Let's do magic. Well, can we do magic tonight? Can we? Let's see if we can do magic tonight. All right, guys, the topic we're going to treat tonight is the one called Alkanoates. The one called alkanoates. Alkanoates. If you heard me loud and clear, put the topic in the comment section, alkanoates. Put the topic in the comment section, alkanoates. If you heard me loud and clear, put the topic in the comment section so that I can proceed. Alkanoates. Alkanoates. All right, let's go. Now, I would like you to understand something. Now, look at this. We're about to treat this part, alkanoates. That's the part we want to treat tonight. Alkanoates. Now, the first thing first, I would like you to understand something. That this group of organic compound, we have what is called alkanals. Alkanals. Alkanals and alkanoates. We have alkanoic acid. Now, we have what is called carboxylic acid. What is called carboxylic acid? What is called carboxylic acid? And we have what is called alcohols. We have what is called alkanols. In the same way, we have what is called alkanoates. Now, this alkanoate is just like a branch of a group of organic compound called esters. Called what? Esters. The esters we mentioned here is not the name of that your friend, which is spelled as E-S-T-H-E-R. No, that's not the one we are talking about. We are talking about the ester, E-S-T-E-R. Ester. Are we clear, please? So when we are talking about alkanoates, we are just trying to look at a group of organic compounds called esters. E-S-T-E-R-S. Esters. Are you with me, please? Now, the first point I would like you to put down is this, that esters or alkanoates are organic compounds formed by the reaction between alkanoic acid and an alcohol. You can put it this way. Let's go by it again. You can put it this way. Listen to me. We can put it this way. We can say that if you want to explain esters or you want to explain alkanoates, now let's go with esters in general. I would say that esters are organic compounds formed by the reaction between carboxylic acid and an alcohol. I repeat, that esters are organic compounds formed by the reaction between a carboxylic acid and an alcohol. Are you with me? Have you gotten that? Have you gotten that? If you've gotten that, just put in the comment section noted. If you've gotten that, just say noted. Carboxylic acid and alcohol. Have you gotten that? Have you gotten that? If you have gotten that, just put noted. Good. Now that simply means that when we say esters, it's just combination of two things. We have carboxylic acid, and we have alcohols. Carboxylic acid and what? Alcohols. Are you with me? But if we are talking about alkanoates, we are going to be specific. We are not going to choose every carboxylic acid. We are going to choose a group of carboxylic acid called alkanoic acid. Called what? Alkanoic acid. When we are talking about the alkanoates, we are not going to choose every alcohol. We are going to choose the group called alkanols. Are you with me? Which means alkanols is a section of alcohols. Alkanoic acid is a section of what? Carboxylic acid. Does that make sense to you? If it does, please put yes, sir, in the comment section so that we can proceed. Now, I want you to remember this thing, that carboxylic acid, or let's just say the saturated aliphatic monocarboxylic acid, if I can put it that way, the saturated aliphatic monocarboxylic acid. That's the one we call the alkanoic acid. The one we call what? Alkanoic acid. Does that make sense to you? And this alkanoic acid, they are represented with the formula RCOOH. So here, this carboxylic acid now, we can now say here is RCOOH plus, and these alcohols, they are represented with the formula ROH. They represent with the formula what? ROH. Follow me sequentially. You need to understand this topic. It's not hard. Are you with me, please? So we have here ROH. Now, for the fact that we have R already in this equation, which is the first one, this R already in this equation, we need to separate this R from this R. Are you with me, please? Now, to separate them, we use what is called a prime. What is called what? A prime. So this one will be RCOOH. This one will not be R prime OH. Now, whether R or you say R prime, both of them are called alkyl group. They are called what? Alkyl group. Alkyl, ALKYL, alkyl group. Does that make sense to you? If it does, put in the comment section, yes, sir, so that we can proceed. All right, Obachuku, we can see that. Esther. All right, we can see that. All right. Okay. Now, what's the next thing then? We have come to realize that esters are organic compounds, right? And they are formed by the reaction between carboxylic acid and alcohols. Are you with me? The carboxylic acid, when it is saturated and aliphatic and has only one carboxyl group, we say that it is saturated aliphatic monocarboxylic acid. I mentioned 3 points. Saturated aliphatic monocarboxylic acid. And that group is called alkanoic acid. So when we combine alkanoic acid, when we combine alkanoic acid and combine it with alkanols, we will not just form any type of ester. We are going to form a type of ester called alkanoates. Called what? Alkanoates. What does that mean? Once it can be your exam question. When the R and the R prime in carboxylic acid and alcohols are saturated, I repeat, when the alkyl group, which is the R and the R prime, are saturated, the ester we are going to form is what is called alkanoate. What is called what? Alkanoate. Does that make sense to you? Does that make sense to you? Does that make sense to you? If it does, put in the comment section, yes, sir, so that we can proceed. Are you with me, please? Now let's go into the business of the day. So now we are going to have this. We're going to have this, that once we have RCOOH combined with R prime OH, it will give us RCOO R prime, right? Plus H2O. Now this one represents alkanoic acid. Alkanoic acid. The RCOOH represents what? Alkanoic acid. The ROH, the R prime OH represents what? Alkanols. I repeat. The RCOOH represents what? Alkanoic acid. The ROH represents what? Alkanols. Why this one represents what? The alkanoids. The alka what? Noids. Are you with me, please? So, the general structure of alkanoids is R, C, O, O, R prime. Is what? R, C, O, O, R prime. Does that make sense to you? Is what? R, C, O, O, R prime. Very, very important. Put that point down, that the general structure of esters or alkanoids is RCOO prime. General structure of esters or alkanoids is RCOO prime. That's the general structure. Have you gotten that? Have you gotten that? If you have gotten it, please put in the comment section noted so that we can proceed. Have you gotten that? Favor Chimamanda, welcome to the live chat. Brother Michael, welcome to the live chat. Now, there is something else I want you to learn. What is that? The next thing we are going to learn now is what is called naming of alkanoates, or should we say IUPAC nomenclature of alkanoates. Yes, how to name alkanoates. Now, you will not just learn how to name it. You should also learn how to convert the name into the structure. Because the first thing I will teach you is how to convert the structure into the name. The second stage is how to convert the name into the structure. Having the two sides will help you in the reactions. Does that make sense to you? Now let's go into it. Now look at this. Look at the structure. R-C-O-O-R prime. I want you to know this, that the R and R prime, they represent what is called alkyl group. What is called alkyl group? Alkyl group. Now, if we want to draw the structure proper, it will look like this. The R bonded to C. This C, we use double bond and bond with one oxygen. I repeat, the C, which is carbon, we use double bond and bond with one oxygen. That is double bond O. And we use single bond and bond with the other oxygen. Don't forget that. The carbon, we use double bond and bond with one oxygen, and use a single bond and bond with other oxygen. So, O, H. In case you see this in your exam, it represents alkanoates or esters. Don't forget this. Exactly. Now, if I can see somebody mentioning carbonyl group here, listen. When we say carbonyl, it's where we have the carbon to oxygen with a double bond. That is the carbonyl group. So look at this. We can see carbon with oxygen that is joined by a double bond, right? That is to tell you that alkanoates are carbonyl compounds. That's what? Alkanoates are carbonyl compounds. Put that point down in your notes. That alkanoates are carbonyl. Carbonyl, C-A-R-B-O-N-Y-L. Carbonyl compounds. Are you with me, please? That's someone type the main oracle. We are not two. There is only one oracle. All right, let's proceed. That alkanoates are carbonyl compounds. Okay, now I want you to learn this thing. Let's go with it now, one by one. We have seen the carbonyl group, right? CO. Yes. Once you can see carbon to oxygen double bond in the functional group, we are suspecting that to be a carbonyl compound. Are you with me? So alkanoates is a carbonyl compound. Now, the next thing we want to learn now is the naming. Naming now. Let's go. The naming of alkanoates. That's the next thing now is the naming. The naming. How do we name the alkanoates? Very, very important. Now remember, they're represented with R-C-O-O-R prime, right? Now, this R prime is coming from the alkanol. What did I say? The R prime is coming from the word alkanol. Don't forget this. So this R prime is coming from where? Alkanol. Please don't forget this. It will help you when you want to form the structure. Very, very important. Why this RCOO is the acidic group which is coming from the carboxylic acid, or let's just call it alkanoic acid. The alkanoic acid. Are you with me? Now, I want you to know this. Anytime, put this point down in your notes. Put this point down. When naming an alkanoate, I repeat, when naming an alkanoate, the R prime group is named first. I repeat, when naming an alkanoate, the R prime group is named first. After which, the acid portion is named as alkanoates. I repeat, I repeat. When naming an alkanoate, the arrow prime group is named first as alkyl. Put it that way. The arrow prime group is named first as alkyl. Have you written that? After which, the acid portion is named as an alkanoate. If you have gotten that, please put in the comment section noted so that I can proceed. If you have gotten that, put in the comment section noted so that I can proceed. All right, let's move on. I will give you examples now. Watch this. If we have something like this, I say something like here will be named as alkyl, right? Right here will be named as alkanoate. I will give an illustration. For example, if we have something like this, let's say we have HCOOCH3. HCOOCH3. Don't be confused. It's simple. This is like saying RCOO arrow prime. So who are we going to name first? The arrow prime, right? Which is our CH3. Now this thing is named first. And if we name this person first, this person is named as an alkyl. And how many carbon are there? Only one carbon. And one carbon in organic chemistry is called what? Met. It's called what? Met. So we're going to call this thing methyl. We're going to call it what? Methyl. Now this remaining portion is what we're going to name next. You see what I'm doing? I'm trying to interchange. The one by the right will be named first, followed by the one by the what? Left. Are you with me? Now, how many carbon are on this side, the acid group? How many carbon? One as well. Right? Remember I told you that the arrow prime is named as alkyl, while the acid group is named as what? Alkanoates. Now, since we have only one carbon is called met, right? So this thing is called metanoids. It's called what? Metanoids. It's called what? Metanoids. So the name of this compound now is what? Methyl metanoid. It's what? Methyl metanoid. Very, very important. Methyl metanoid. Very, very important. Are you with me? I will give you another example. Look at this example. Put this example in your notes. This is methyl metanoid. HCOOCH3. Methyl metanoid. So metanoid is H and COO. Take note of that. I say that metanoid is what? H and what? COO. I will use that in later. Now, we have another example. Another example is CH3 COO with C2H5. Some textbook may not write it this way. They will write it this way. CH3 or CH3COO, CH2, and CH3. Anyhow you see it, both of them are the same. Anyhow you see it, both of them are the same. Are you with me? Anyhow you see it, both of them are the same. Follow me. This C2 means we have how many carbon? 2. Carbon 1 and carbon 2. That is C2. 2 plus 3 is what? 5. That means hydrogen is 5. Both of them are the same. Now, what are we going to name first? We are going to name the right, which is the arrow prime side. We are going to name this side first. And this side has how many carbon? 2. And they should be named as alkyl. The arrow prime is named as alkyl. Don't forget that. So we call that part ethyl. Thank you. Ethyl. Somebody said that in the chat. Ethyl. Why this part? Look up. Very, very important. It's named as what? This remaining CH3COO will be named as, look at it. How many carbon are there? We have the first carbon forming the COO. And we have the other carbon forming the CH3. They have 2 carbon now. So we now call it ethanoid. We now call it what? Ethanoid. So if I ask to write ethanoid only for me, does you come to your mind is CH3 and COO? Do you get that? Do you get the beat now? Do you get the beat? We're about to form a song. Oh, that's by the way. That ethanoate, CH3 and COO. Methanoate, H and what? COO. We are going to use it later. When we want to form the structures, we are going to use it. It should be easy. It should be fun. Let's move on. All right. Now, this is ethyl ethanoate. Does that make sense to you? Remember the trick. Name the right before the left. Name the arrow prime before the acid side. Very, very important. Someone typed mind explosion. Yes, somebody's mind should be exploded tonight. Tonight, I'm going to finish everything under Alkanoates. Everything. What the things you've heard before and the things you've never heard. So we are starting from the known and we are going to move into the unknown. Stay with me. All right. At least you have seen how to name these. I will write the other one, the next one. I want you to attempt it for me. Let's go. We have this example. CH3, COO, CH3. We also have this example. CH3, CH2, COO, CH3. How do we name this? Do you know the name? Put the name in the comment section, please. What's the name of the first one? CH3, COO, CH3. What's the name? What's the name? What's the name? Someone said methyl ethanoate. Yeah, methyl ethanoate. Emmanuel Kelechi, Oracle, you too much. The world knows that. Thank you. The other one. You have gotten that, right? Let's go to the second one. What do you think will be the answer? CH3, CH2, COO, CH3. Favorite mother said methyl propanoate. That's correct. Don't forget the trick. It's very, very simple. Name the right before the left. Name the alkyl group, that is the arrow prime, that is coming from the alkanol. Right? This thing I just said, I'll use it and ask you a question. I believe you will get it. Now for this one, we name this part first, which is the methyl. The methyl. Then we name this one secondly, and this is called what? How many carbon? 2 carbon. So this is methyl ethanoate. Right? Now, this is the first one. How many carbon? 1. Going to call it what? Methyl. That is the arrow prime side. So we call it methyl. Now look at this side. How many carbon are here? 1, 2, and 3. 3 is prop in organic chemistry. True or false? True or false. So we're going to call it methyl what? Propanoate. Now, we are going to form a song. Are you with me? Remember, in ethanoate, we have CH3 and COO. In propanoate, we have CH3, CH2, and COO. You need to capture that thing I'm saying now. I'll use it. Are you with me? I said in methanoate, we have H and COO. Ethanoate, CH3 and COO. Are you with me? Propanoate, CH3, CH2, and COO. Capture that again. Methanoate, H and COO. Ethanoate, CH3 and COO. Propanoate, CH3, CH2, and COO. Are you with me, please? The word we learn organic chemistry in another dimension. Learning should be easy and fun. It shouldn't be stressful. You don't understand because you have not been taught by a powerful tutor. Get the point now. Let's go. Don't forget our trick that methanoate, H and what? COO. Ethanoate, CH3 and COO. Propanoate, CH3, CH2, and COO. Very, very important. All right. Now, this is the time for me to test your brain with one question. The question says, put it down, everybody. Put it down, everybody. Put it down in your notes. The alkanoate CH3, COO, C2H5. Let me write on the board, so not give me excuse. The alkanoate, the alkanoate CH3, CH2, I think that's the question. CH3, CH2, COO, C2H5. The alkanoate CH3, CH2, COO, C2H5. Yeah. Is the product of the reaction. Put it down, I repeat. The alkanoate CH3, CH2, COO, and CH2, okay, sorry, CH3, CH2, COO, C2H5, right? Is a product, yeah, is a product of the reaction between dash and dash. Is a product of the reaction between dash and dash. Is a product of the reaction between dash and dash. Please do well to give us a thumbs up in our live stream. Give us a thumbs up in our live stream, please. Give us a thumbs up. Not just the love emoji. Give us a thumbs up in our live stream. It's a product of dash and dash. Option A, ethanoic acid and ethanol. Option A, ethanoic acid and ethanol. Option A, ethanoic acid and ethanol. Option B, ethanoic acid and methanol. Option C, propanoic acid and ethanol. Option D, propanoic acid and methanol. What do you think will be the answer? What do you think will be the answer? Option A says, Option A says, what do you think will be the answer? What do you think will be the answer? Remember what I told you earlier, that the arrow prime, which you name first as a key, is coming from where? Alkanol. This young man first, CH3, CH2, COO, C2H5. The name of that compound first is ethyl propanoate. Is what? Ethyl propanoate. That's the name. So that first part of the name is coming from alkanol. It's coming from where? The word alkanol. So ethyl is coming from ethanol. Does it make sense to you? The propanoate is coming from propanoic acid. Are you clear? The ethyl is coming from where? Ethanol. The propanoate is coming from where? Propanoic acid. So the correct answer to this question is option what? C. That which is is a product of a reaction between propanoic acid and ethanol. Does that make sense to you? Please put the question down in your notes. Put the question down in your notes. The option A says ethanoic acid and ethanol. Option B, ethanoic acid and methanol. Option C, propanoic acid and ethanol. Option D, propanoic acid and methanol. Help us to share this link to your class group so that others can join. This is not their regular. It's not their regular. All right, so let's proceed. Very good. Now, I want us to say something. Now, I promise you guys something. We're going to start from the known to the unknown. I want us to look into another subtopic called the natural sources of alkanoates. Put that as a heading in your notes. Natural sources of alkanoates. Natural sources of alkanoates. The natural sources of alkanoates. Put it down in your notes. The natural sources of alkanoates. Have you gotten that? The question is, where can we get these alkanoates? 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 That's the question. Oh, this is trying to restrict some things. Okay. The question, where can we get these alkanoates? That's the question. I want you to know this, that esters, that they occur naturally in many plants and animals. Yes, they occur naturally in many plants and animals, especially in fruits, flowers, and essential oils. I repeat, especially in three things I mentioned now: fruits, flowers, and essential oils. Now, just notice that esters, they are responsible for the sweet smell of flowers. I repeat, you can put that point down, that esters are responsible for the sweet smell of what? Flowers. Now, that is to say that the flowers rely on esters to attract pollinators. That the flowers rely on what? Esters to attract what? Pollinators. Does that make sense to you? Now, remember I said that esters, that they occur naturally from many plants and animals, right? Especially in fruit, flowers, and essential oils, right? Now, the next point I want you to know is this, is that many fruits are aromatic and their flavors are due to what? Esters. I repeat that many fruits are aromatic and their flavors are due to what? Esters. Sometimes in exam, they will ask you, which of the following organic compounds has a fruity smell? Look for alkanoates. Look for alkanoates. Which of the following organic compounds has a fruity smell? Look for what? Alkanoates. Does that make sense to you? Good. The next thing I want you to know is this, that some of these alkanoates, they can be seen in different fruits. If you bring your banana now, the smell that it has, that smell is similar to that of pentyl ethanoate. That is to tell you your banana contains what? Pentyl what? Ethanoate. Pentyl ethanoate. Pentyl is C5H11. Are you with me? While your pineapple contains what is called ethyl butanoate. What is called what? Ethyl butanoate. Let's put that on the board. Very, very important. I say that they are seen in this. Okay. What's the next first fruit I mentioned there? The first I mentioned is what? The pentyl what? Ethanoate. So that the banana has what? The pentyl ethanoate. Pentyl ethanoate. Pent is how many carbon? 5, right? So we have C. Now, if you want to put the structure, okay, I think this is the right time to teach you this thing. I made mention of the other one. Which other fruit did I mention? I made mention of pineapple, right? Yeah, good. Pineapple. And then said it has what? Which fruit? Let me get this. Sure, this one is not writing well. It has ethyl, yeah, ethyl butanoate. Ethyl butanoate. Now, guys, if you want to write the molecular formula, just interchange. Don't just rush and write. Interchange. Look up. Look up. Look up. Very, very important. Look at this. This is pentyl, right? Pent is how many? 5. I will take it to the right. Take it to the what? To the right. To the left. To the right. Oh, sorry. We are on live, please. Let's get back. So we have this. I'll write the pentyl. C5. Pent is 5. Alkyl are represented with the formula C5H11. C5, the pentyl here, the alkyl here is C5H11. They are going with the other formula CnH2n plus 1. Don't forget this. That's alkyl has the formula CnH2n plus 1. Are you with me? So for the fact we've mentioned pentyl, pent is 5 carbon. Pent is what? 5 carbon. So it will be 2 times 5, 10 plus 1 what? 11. So this pentyl is C5H11. Are you with me? C5 what? H11. Now we'll give you a trick. What I normally do. Let's go. So this is ethanoate, right? Do you remember when I told you guys something about ethanoate? That it's CH3COO. What is ethanoate? CH3COO. Right? But sometimes I don't like using that method. Because what if they ask me, what of decanoate? Do I need to start doing CH3, CH2, CH2, CH2? Before we finish the CH2, I must have collapsed in the classroom. So I will tell you what to do now. Now we have gotten pentyl, C5H11, right? Look at this, ethanoate, right? Earth is how many carbon? 2, right? I will use my mind and say O8. Everybody say O8. O8. That O8 here I will represent with COO. That O8 I will represent with what? COO. So here I will have COO. Are you with me? Remember the name is ethanoate. Earth is 2 carbon. And I've used 1 carbon. How many carbons are remaining? 1. Does that make sense to you? I repeat. Earth is 2 carbon. I have used 1 carbon already, COO. How many are remaining? 1. So that 1 carbon will be used for CH3 only. I will use that 1 carbon and form an alkyl group, and it will form CH3. Because if I apply the formula CnH2n plus 1, and if n is 1, 2 times 1 is 2, plus 1 is 3, it will give me CH3. Hey, I don't know if you get this thing I just said now. I don't know if you get this trick. I will go over it again so that you will understand. Let me go over it again. The secret is this. The secret is this. Once you have written the formula of the alkyl, write it at the right because it represents the arrow prime. And you want to write the other one at the left. Use the word O8 and form and write COO first. Like here, this is pentyl ethanoate. If I write the pentyl, which is C5H11, how? By using the formula of alkyl, CnH2n plus 1, right? When n is 5, 2 times 5 is 10 plus 1, 11. That's why we have C5H11, right? Now we use the word oate and write COO. I've written COO. Now, what is the name of that thing? Ethanoate. Et means two, but I've used one. What is remaining? One. When my carbon is one, which alkyl group will I form? Methyl. And what is the formula? CH3. So the formula of this pentyl ethanoate is CH3 COO C5H11. And that is present in what? The bananas. Are you with me? Now, when it comes to pineapple, where we have ethyl butanoate, what's the first thing I will write there? This is ethyl, right? Ethyl. And the formula of ethyl is what? C2H what? 5. Using the formula CnH2n plus 1. Are you with me? So when the N is 2 now, it will be 2 times 2, 4 plus 1, 5. So this is C2H5 for the ethyl. I want to form butanoate. I will use the word oate and write COO. COO. But is how many? 4. But I've used 1. How many is remaining? 3. And that 3 is prop. If I want to use it and form alkyl, we call it propyl, okay? And prop, if you want to form propyl, it is C3H7. So here will be what? C3H7. Is that way? C3H7, COO, C2H5. In exam, they may give you this thing and ask you to name. I want to tell you one thing, first thing they will do to you. One of the first option will be ethyl propanoate, because they know you will ignore this carbon and see this 3 and call it propyl. Don't make that mistake. When you are naming the left-hand side, count the carbon that has the COO. Take note of this thing I'm saying now. This is possible mistakes you make in exam hall. And you come out and start shouting, I knew what I wrote, blah, blah, blah. When the result comes out, what you wrote, we know you. Oh, God. Are you with me? So this is the secret you should know. This C3H7COO, this C is part of it. Are you with me? If you want to name it, this C3 plus C is what? 4. It is butanoate. Please, don't make that mistake in exam. Are you clear, please? I hope you are cleared. I believe you are clarified. The oracle is talking. You're supposed to understand now. It's normal. It's expected. Can we proceed? Can we proceed? If you want us to proceed, just put down right on paper. Let's move. Let's move. Let's move. If you want us to proceed, some touch video. Right on paper. Let's move on. You must understand. I'm finishing this topic tonight, and you must understand. Nothing can stop you from getting it. Just stay with us to the end. Listen attentively. You must understand. Now I have the next thing for you. At least you have gotten something now. Suppose know that that pentyl ethanoate is present in banana now. Normally. Not that could they teach you. You suppose know new thing. And you suppose know that ethyl butanoate is present in what? Pineapple now. Normal level. You done minutes. Okay, let's move on. Now we're moving into what is called isomerism in esters. The isomerism in alkanoates. The same way we have structural isomerism in alkanes and others. Remember the meaning of the term isomerism? The process whereby different compounds have the same molecular formula, but different structural arrangement. The same molecular formula, but different structural arrangements. We're going to look into this. Now, the isomerism we want to look into is not just for every other compound. We are looking into the isomerism that concerns a group of organic compound called alkanoates. Called what? Alkanoates. Are you with me, please? Are you with me? Okay. Let's move on. Isomerism. The isomerism here. Oh, God. I believe by now you must have gotten one or two, but now listen to me. The isomerism we see in alkanoids, we have two major ones, two major types. We have the structural isomerism and we have the functional group isomerism. Very, very important. They will test you more on functional group isomerism in exam because they know that you can easily get the structural isomerism. That's why they'll be more interested in the functional group isomerism. Are you with me? But no both of them in case of necessity. So now here we have the first one here to be structural isomerism. Structural isomerism. The number two, we have functional group isomerism. Functional group isomerism. Put it down in your notes. Now we have number one, structural isomerism. The number two, the functional group isomerism. The functional group isomerism. The functional group isomerism. Okay, put these points down. We are starting with structural. That's alkanoids with 3 or more carbon atoms exhibit structural isomerism. But remember, this structural or chain isomerism is seen in alkane with at least 4 carbon. Take note of that. That's why you will tell me that that butane has 2 isomers. Have you forgotten? The first one is 2-methylpropane and the second one is N-butane. Are you cleared? I'm taking you back to alkanes. You should be in the mood of organic chemistry. If you are moving from alkanoid to alkane, you are still there. If you're moving to alkene, you are still there. You should be well loaded, well informed, well stuffed in organic chemistry, so that when you speak, the world will hear you. All right, let's proceed. I said that alkanoids with 3 or more carbon exhibit structural isomerism. Very, very important. Very, very important. Exhibit structural isomerism. Very, very important. Okay, what's the next thing we need to know? And what are the examples here? Example. Let me give you this compound. Look at this. C3H6O2. You see this thing? It can represent 2 alkanoids. Yes, it can represent 2 alkanoids. How? It can represent the alkanoids called ethyl metanoids. We can use this and form ethyl metanoids. And we can also use it to form what is called methyl ethanoids. Methyl ethanoids. Bro, I have one trick I normally use. I just want to give you the trick now for structural isomerism. Should I give you? Are you sure you want me to give you? Sometimes I will just rearrange the carbon. Look at this. Ethyl metanoid. Now it's now methyl ethanoid. Is your brain telling you something? You can use this and start it, and you form a structural isomer. Are you cleared? Are you cleared? Ethyl metanoid is a structural isomer of what? Methyl ethanoid. I will turn it upside down. If I don't know much, I need to have something I can say. Are you with me? That ethyl metanoid is a structural isomer of what? Methyl ethanoid. Are you in the same spirit with me? Can we proceed now? Can we proceed? Hey, God of Israel. Can we proceed? Can we proceed? Now, I will show you something. Remember, I say that isomerism is that phenomenon whereby different compounds have the same molecular formula but different structural arrangements. Look at this. I said that C3H6O2 can be used to represent ethyl metanoate and methyl ethanoate, right? Now, let's write the formula of ethyl metanoate now. Does it make sense? Now, the formula, who is the first person? Ethyl or choir? Ethyl, right? Ethyl. Earth is how many carbon? 2, right? Ethyl is C2H5. Using the formula CnH2n plus 1, 2 times 2, 4 plus 1, 5. So C2H5. You get the point now. So there we have C2H5. Right? That C2H5 now represent the ethyl. We want to write now the metanoate at the back. Remember what the trick I told you. Oate, write COO. Write what? COO. Remember, the name is met, right? We have removed the one carbon. So nothing else is remaining. We only put what? Hydrogen. So ethyl metanoate is HCOOC2H5. I repeat, HCOOC2H5. Very, very important. Not just COOC2H5. Let me show you how. Why must I put the hydrogen? Oracle, why must you put the hydrogen? I'm trying to respect carbon because it's the father of the organic chemistry. And to respect carbon, you must maintain the tetravalency of carbon. Anywhere carbon is, must be bonded to up to 4 different things. So remember, we have C2H5. This is C2H5. H should be here. H should be here. H should be here. Does it make sense? C2H what? 5. Now they are now bonded to COO, right? So this is C. This is C now. Double O with another O bonded to this. Bonded to this. Now the remaining carbon now has how many bonds? 1, 2, 3. Something is remaining. And that is remaining should be what? Hydrogen. That's why I said HCOO C2H5. Very, very important. You must respect carbon. Yes, give respect to carbon by maintaining the tetravalency of carbon. Is that okay with you? So the next is methyl ethanoate. Methyl, 1 carbon, CH3, right? So we have CH3. Ethanoate. Oate, we put COO, right? COO. Remember, it is ethanoate, 2 carbon, but you have used 1 carbon already. How many carbon is remaining now? 1. We use it and form CH3. CH3. So CH3COO CH3 represents what? Methyl ethanoate. If they give you that in exam, in the options, you will have methyl metanoate as option A. Please don't make the mistake of clicking that. Why? They want your mind to be seeing only CH3. So you'll be thinking of the word metanoate. Are you with me? And when you mistakenly choose the metanoate, you will fail annoyed. Don't mind me, please. don't make that mistake. Remember, the CH3 and C will come together to be what? 2 ethanoate. Very, very important. Can we proceed? Can we proceed? Can we proceed? If you want us to proceed, put in the comment section, fire on daddy. Can we proceed? Can we proceed? Can we proceed? Someone just type fell and know it. Hey, you know, I'm always here to give you the secret to expose you so that you will not go and make mistake. I want you to smash 90-something organic chemistry, 97 over 100. It's possible. You can do that. You have what it takes to do that. You have the best in the game teaching you. So why shouldn't you get 90-something? I'm not surprised if you get it because you have what it takes to do that. All right, let's proceed. Now, the next thing is, we have given the first example. So what you write in your notes is that ethyl metanoate is a structural isomer of methyl ethanoate. You can put that in your notes. That ethyl metanoate is a structural isomer of methyl ethanoate. Very, very important. And both can be represented with the molecular formula C3H6O2. Both can be represented with the molecular formula C3H6O2. If you look at them, you see that both of them have 3 carbons. Both of them have what? 6 hydrogen. Both of them have what? 2 oxygen. Very, very important. Have you gotten that? Have you gotten that? Have you gotten that? Okay. Now, the next example we are going to pick is C4. This will be long, but we need to look at them all of them. 1 minute. C4H8O2. C4H8O2. Can you tell me one structural isomer of that? Put in the comment section. Let me see if you know what you are doing. Have you gotten that? Give me one example that we have, one alkanoate that we have C4H8O2 as its molecular formula. Any attempt? Someone said ethyl ethanoate. That's perfect. Reckoning explainer. That's good. Ethyl ethanoate is common sense. Eth and eth is 4. Another person has said methyl propanoate. That's correct. That's correct. That's correct. That's correct. That's correct. Now listen. The first that should come to your mind is ethyl ethanoate. So remember, eth and eth is 2. The other eth is 2. 2 plus is what? 4. So we can also have methyl propanoate. Met is how many? 1. Prop is how many? 3. 1 plus 3 is what? 4. You know the next game is to turn it upside down and the prop will come this side. So it will now be propyl metanoate. Then it's remaining 1. I know you may not be able to get that one. Let me help you with that. The name is 1-methyl ethyl metanoate. 1-methyl ethyl metanoate. I'll write the structures for you guys to take note. That is to say that what's it called? The alkanoates with the molecular formula C4H8O2 has how many structural isomers? 4. But the other one of C3 has how many structural isomers? 2, of course, right? Okay. So this one, ethyl ethanoate, is C2H5 here. This side will be CH3COO because ethanoate is COO, right? Now, methyl propanoate, methyl CH3. Propanoate is what? CH3, CH2, and COO. Again, CH3, CH2, and COO. So we are going to have here CH3, CH2, and COO. Propyl metanoate. Prop is how many carbon? 3. So we have C3H7. Metanoate is HCOO. H and what? COO. Metanoate is what? H and what? COO. So we have HCOO CH3. C3H7, sorry. Now this one, 1-methyl ethyl metanoid. This is like the branch. 1-methyl is a branch. Ethyl here is C. Let me put it this one, CH2, CH3. It simply means C2H5, right? Now, this is the metanoid, HCOO. But because I want to attach a branch, which is 1-methyl at the position 1, which is this carbon, I will remove the other hydrogen. Here, we're going to have a branch here. Down here, we're going to have CH3. So this is 1-methyl ethyl metanoid. 1-methyl ethyl metanoid. Very, very important. Very, very important. Very, very important. Now let's go to the next. Let's go to the next. On to the next. We have treated the structural isomerism. The next we are going to look into is what is called the functional group isomerism. What is called the functional group isomerism. Functional group isomerism. Let's be fast. We are treating everything tonight. Everything. Functional group isomerism. Put this point down in your notes. That alkanoates exhibit functional group isomerism. I repeat, alkanoates exhibit functional group isomerism. Alkanoates exhibit functional group isomerism with one or more alkanoic acid. Alkanoates exhibit functional group isomerism. Have you written that? With one or more alkanoic acid. Have you written that? Have you written that? If you have written that, please put noted, please, so that I will proceed. If you have written that, put noted so that we proceed. If you have written that, put noted. Rocking Explainer, you active. Patrick, you active. All right. Now, I say that alkanoates exhibit functional group isomerism. What do you mean by functional group isomerism? Whereby organic compounds from different homologous series have the same molecular formula. I repeat, organic compounds from different homologous series have the same molecular formula, which means this isomerism, because they are from different homologous series, they will have different functional group. Hope you are aware. But in the case of alkanoates, they're exhibiting this functional group isomerism with a group of organic compound called alkanoic acid. Called what? Alkanoic acid. Examples. Number 1, methyl metanoate and ethanoic acid are functional group isomers. Take note of that. They will ask you an exam. Which of the following is a functional group isomer of methyl metanoate? The answer is ethanoic acid. Take note of that. I repeat, someone said I should repeat. Methyl metanoate is a functional group isomer. It's a functional group isomer of ethanoic acid. Or you just say methyl metanoate and ethanoic acid are functional group isomer. Anywhere you want to put it. Number 2. The first one I say is methyl metanoate. Should I even put it on the board? The first one I said is methyl metanoate. Now the second one number 2, methyl ethanoate, met and et, methyl ethanoate, methyl ethanoate. Methyl ethanoate is a functional group isomer of propanoic acid. I will give you a trick of what you will know. I will burst your bubbles. I'll give you a trick of what you should know. It's a functional group isomer of propanoic acid. Have you written that? Lastly, okay, before that, right, both have the molecular formula C3H6O2, methyl ethanoate and propanoic acid. Both have the molecular formula C3H6O2. Very, very important. Have you gotten that? Next point. Ethyl ethanoate now. Ethyl ethanoate. Ethyl ethanoate is a functional group isomer of butanoic acid. Is a functional group isomer of butanoic acid. Is a functional group isomer of butanoic acid. Have you written that? Ethyl ethanoate is a functional group isomer of butanoic acid. Have you gotten that? Both have the molecular formula C4H8O2. Both have the molecular formula C4H8O2. They may not ask you the molecular formula, but know that, what's it called? The functional group isomer. That methyl methanoate is a functional group isomer of what? Ethanoic acid. And methyl ethanoate is a functional group isomer of what? Propanoic acid. And ethyl ethanoate is a functional group isomer of what? Butanoic acid. Should I give you a trick or what, or how to know it? Somebody type, give me a trick. Just type trick. Just type trick in the comment section. Let me give you a trick now. Just type trick in the comment section. I will give you a trick what to know now. Now listen. It's very simple. If you check out your notes, you will see that I said methyl methanoate, right? I mentioned two things. The first one is, watch out, methyl methanoate. Met is how many carbon, please? Met is how many carbon? 1. Look at the name again. Methyl methanoate. Methyl methanoate. 1 plus 1 is what? 2. And 2 is what? 8. So methyl methanoate is a functional group isomer of ethanoic acid. Do you get the point? Do you get the trick now? Met is 1. Methanoate is 1. 1 plus 1 is 2. And 2 is 8. So methyl methanoate is a functional group isomer of ethanoic acid. That one is not in your textbook. It can only come from Oracle now, normally. Get enjoy. All right. Let's go. Look at the other one. We have methyl ethanoate, right? Met is 1. Ethanoate is 2. 1 plus 2 is 3, which means methyl ethanoate is a functional group isomer of propanoic acid. I go again. Met is 1. Et is 2. 1 plus 2 is 3, which means methyl ethanoate is a functional group isomer of propanoic acid. Are you with me, please? Are you with me, please? Hey, God. Are you getting the trick now? Now look at this. Ethyl ethanoate. Et is 2. Et is 2. Et is 2. 2 plus 2 is 4, which means ethyl ethanoate is a functional group isomer of butanoic acid. Oh God. Oh God. So we should go into the world and make learning easy and fun. He has given us the grace to go into the world and make this learning easy. That willing mind should learn and understand. Can we proceed? Hey, God. Now let's move to the next. You have gotten the trick. You have gotten enough trick for today. You have gotten enough trick. Let's move to the next thing. The next thing says, hey, don't forget that trick. Oh. Don't forget it. Don't forget it. Don't even try it. Don't even try it. Don't even try it. That methyl metanoate is a functional group isomer of ethanoic acid. Methyl ethanoate is a functional group isomer of propanoic acid, right? And ethyl ethanoate is a functional group isomer of butanoic acid. Use it and form a song. Let's move on. I have a point you must write in your notes. And that point says, when the molecular formula of a compound is written as CN H2NO2. Very, very important. When the molecular formula of a compound is written as CN H2NO2, is written as CN H2NO2. Have you gotten that? It may represent an alkanoic acid or an alkanoate. I've seen where they use that to ask question one certain time. I think whether it's jump pass question or what, I can't really recall. When the molecular formula of a compound is written as CnH2NO2, it may represent an alkanoic acid or an alkanoate. Very, very important. Very, very important. Now let's move into the next thing. The next game of the day. And that is what is called preparation of alkanoids. Preparation of what? Alkanoids. Someone put in the comment section, prepare, so that we can proceed. Preparation of alkanoids. The preparation of alkanoids. Preparation of alkanoids. Oh God. If you want us to prepare this alkanoid, put in the comment section, prepare, so that we can prepare this alkanoids and give you guys. Currently, Emmanuel Christian is topping the chart, followed by Esma Franklin, followed by Ebere Sussex. So these are the top fans currently. So there's a chance to win something in this live stream. Okay. I will mention like two major methods we can use to prepare alkanoic acid. Number one, put in your notes, preparation of alkanoid. Two major methods we can use to prepare alkanoids. Number one is esterification reaction. Esterification. Number one, write in your notes, esterification. Number two, in your notes, write reaction of acyl halides with alkanols. And repeat, the number one is esterification. Number two, reactions of acyl, ACYL, acyl halides with alkanols. But the most important one is esterification reaction. The most important is esterification reaction. The most important is esterification reaction. The most important is esterification reaction. I think this is the best method we can use. Instead of you sleeping in night class, you give us your topic you want to read for the night. We trash it down. It will help you. Imagine when I'm done with these alkanoates. If you open it, it will be like something meant for children. All right, that's by the way. Now let's pick it. 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 Now the first we are taking is esterification. Before we go into esterification, I want you to understand something about esterification. It involves two things. One is an alkanoic acid. Two is an alkanol. I repeat, I had a network interruption. Let me proceed. I repeat. That in esterification, it involves two things, alkanoic acid and alkanol. Alkanoic acid, like representing the acid you know in your inorganic chemistry. The alkanol is like representing the base you know in your inorganic chemistry, right? Now, in this reaction, it requires a catalyst, not just anyhow catalyst, but an acid catalyst. And what? Acid catalyst. So someone can tell you that esterification is acid catalyzed. What did I say? Esterification is what? Acid catalyzed. It requires a mineral acid as a what? A catalyst. And the mineral acid we normally use is concentrated H2SO4. Is what? Concentrated H2SO4. Are you with me? Now I want you to know this, that the concentrated H2SO4 serve two purposes. One, it is serving as a catalyst. Two, it is serving as a dehydrating agent. I mentioned two things, that the acid there is serving as a catalyst and as a what? Dehydrating agent. Remember that in esterification reaction, it involves alkanoic acid and alkanol. They will react to form an ester, also called alkanoates, and water. We need to remove that water so that we can get our alkanoate, which is an ester. And that is the work of the concentrated H2SO4. It is catalyzing the reaction and also serving as a dehydrating agent. That reaction, whereby you remove water molecule, is called dehydration. It's called what? Dehydration. Does that make sense to you? If it does, put in the comment section, yes, sir, so that we can proceed. If it does, put in the comment section, yes, sir, so that we can proceed. All right. Now, in esterification, let's pick that, esterification. Here we have esterification. What happens? We have RCOOH combining with R prime OH in the presence of acid catalyst. Sometimes they will use hydrogen ion and put there. That hydrogen ion represents an acid, mostly H2SO4, the concentrated form of it. So here we have RCOOR prime plus water. So for us to, this is the ester, or you call it the alkanoate. The alkanoate. For us to obtain this alkanoate, we need to remove this water. And the person that will remove it is a dehydrating agent. We are serving as a dehydrating agent, the acid we use to catalyze the reaction. Does that make sense to you? Now, I want you to understand this. That esterification reaction is reversible. It's what? Reversible. Are you with me? And it is acid catalyzed. Unlike neutralization reaction, which also involve acid and the base, the neutralization reaction is not reversible and it's not acid catalyzed. It can be I wish that in some skills that write theory questions, they can ask this question: difference between esterification and neutralization. Don't forget that esterification is what? Reversible, and the reverse of esterification is called what? Hydrolysis. It's called what? Hydrolysis. We can call it usually acid hydrolysis. Thank you. Usually acid hydrolysis. We also have alkaline hydrolysis. We will still come to that. So acidification is reversible. Neutralization reaction is what? Irreversible. Acidification is acid catalyzed. Neutralization is not acid catalyzed. Acidification involves alkanoic acid and alkanol. Neutralization involves an acid and a what? A base. Okay. Okay. So put these points down. Acidification, put these points down. Put these points down in your notes. Acidification is the reaction between an alkanoic acid. I repeat, acidification is the reaction between an alkanoic acid and an alkanol. It's a reaction between an alkanoic acid and an alkanol in the presence of an acid catalyst to form an alkanoate and water. In the presence of an acid catalyst to form an alkanoate and water. I've written that. If you have gotten that, put in the comment section noted so that I will know you have gotten that. Have you gotten that? If you've gotten that, put in the comment section noted. All right, let's proceed. The general reaction is RCOOH plus R prime OH. Then you put a reversible this thing and write RCOR prime plus water, H2O. Write that equation under it. Write that equation under it. Write that equation under it. Have you gotten that? Have you gotten that? Next point, when ethanoic acid reacts with ethanol, when ethanoic acid reacts with ethanol, have you gotten that? It gives ethyl ethanoate and water. When ethanoic acid reacts with ethanol, it gives ethyl ethanoate and water. When ethanoic acid reacts with ethanol, it gives ethyl ethanoate and water. Ethyl ethanoate and water. Have you gotten that? Have you gotten that? Ethyl ethanoate and water. Okay. Okay. Next point you should know is this. The next point you should know. Note, acidification is similar to neutralization. Acidification is similar to neutralization. Have you written that? However, acidification is a reversible acid catalyzed reaction. It's a reversible and acid catalyzed reaction. However, acidification is a reversible and acid catalyzed reaction. Have you written that? Next point. The concentrated acid used in the reaction, serves as a catalyst as well as a dehydrating agent. I repeat, the concentrated acid used in the reaction serves as a catalyst as well as a dehydrating agent. As well as a dehydrating agent. Have you gotten that? Have you gotten that? Now, the next point we should know is this. Note, in esterification, heating is required. Heating is required. Very, very important. In esterification, heating is required. In esterification, heating is required. Very, very important. Very, very important. Now, the next we're going to look into, we're almost done. But before we even end the class, we're going to have question and answer series. Yes, I will throw you questions to be sure you have been with me from the beginning to the end. Okay, let's proceed. Put in your notes down physical properties of alkanoids. The physical properties. The physical properties of alkanoids. Put in the notes physical properties of alkanoids. Physical properties of alkanoids. The first point is this, that they are colorless liquids they are colorless liquid. Put it down. They are colorless liquids with a pleasant fruity smell. Colorless liquid with a pleasant fruity smell. With a what? A pleasant fruity. F-R-U-I-T-Y. Fruity smell. They are colorless liquid with a pleasant fruity smell. Have you written that? Have you written that? The next point is that the lower members are soluble in water. Lower members are soluble. The lower members are soluble in water. Number 3, their solubility decreases. Their solubility decreases. Their solubility decreases with an increase. Their solubility decreases with an increase in molecular mass. Their solubility decreases with an increase in molecular mass. I've mentioned 3 physical properties now. The first one is that they are colorless liquids with a pleasant fruity smell. Which of the following organic compound has a pleasant fruity smell? The answer is alkanoid. Number 2 property, the lower members are what? Soluble in what? In water. Number 3, their solubility decreases with an increase in what? Molecular mass. We've gotten that. Now let's go into the chemical reactions or the chemical properties. Very, very important. Chemical reactions or chemical properties. Put that down. Chemical reactions or chemical properties. The chemical reactions, that's where we are. The chemical reactions. Okay. Now, I want you to know this, that alkanoates, they have 3 major reactions I would like you to know. The first is what is called acid hydrolysis. What is called what? Acid hydrolysis. The second is what is called alkaline hydrolysis. What is called what? Alkaline hydrolysis. The third is what is called ammonolysis. Or what is called what? Ammonolysis. I have mentioned the first one, which is called the acid hydrolysis. Acid hydrolysis. The second one is alkaline hydrolysis. The third is what is called ammonolysis. What is called ammonolysis? what is called ammonolysis. I've mentioned three things there: acid hydrolysis, alkaline hydrolysis, ammonolysis. Are you with me, please? Are you with me? If you're with me, just type, I'm with you. I'm with you. There's this song normally say, I'm with you, my yori yori. Let's proceed, please. Hey, good. All right, all right, all right. Now let's pick them one by one. First of all, we need to understand the term lysis. To break down. Yes. We are trying to break it down. Hydrolysis. We're using water. If you're using it in the presence of an acid, we call it acid hydrolysis. Does that make sense to you? If you're doing that hydrolysis in the presence of a base, we call it an alkaline hydrolysis. If you're not using water, we are now using ammonia. We call it ammonolysis. We call it what? Ammonolysis. Does that make sense to you? So take this point from me now. Put this point down. Acid hydrolysis of alkanoates gives an alkanoic acid and an alkanol. I repeat, acid hydrolysis of an alkanoate gives an alkanoic acid and what? Alkanol. Very, very important. Have you written that? It is done by refluxing. REFLUXING. It is done by refluxing a mixture of alkanoates and water in the presence of concentrated H2SO4. In the presence of concentrated H2SO4. I repeat, acid hydrolysis of an alkanoate gives alkanoic acid and alkanol. Don't forget that. It's a potential exam question. Have you written that? Another point you should know is alkaline hydrolysis of an alkanoate. Alkaline hydrolysis of an alkanoate. Have you written that? Gives a sodium, give it this way. Alkaline hydrolysis of an alkanoate gives a salt of the alkanoic acid and an alkanol. When it comes to acid hydrolysis, it gives the alkanoic acid itself and an alkanol. When it comes to alkaline hydrolysis, it gives what? A salt of the alkanoic acid and an alkanol. Have you seen that? Have you seen that? Have you seen that? Have you seen that? Another point you should know is this. Acid hydrolysis of alkanoates is reversible, whereas the alkaline hydrolysis is not reversible. Acid hydrolysis of alkanoates is reversible, whereas the alkaline hydrolysis is not reversible. Have you gotten that? Have you gotten the point? Have you gotten that? All right, let me give you this. Let me give you this. We have touched a lot. Okay, we have this CH3 COO C2H5, which is called ethyl ethanoate. Let's assume it's undergoing acid hydrolysis with water. Remember, this one is reversible in the presence of an acid. That's why I put hydrogen ion here. It will break this into two. Hydrogen, remember, water is a combination of hydrogen and what? OH. One hydrogen will join here. And we are going to have CH3, COO. The first thing is that there will be hydrolysis. They will break this thing into two. Yes. CH3, COO, and the H plus, this is C2H5. OH will join to it. C2H5OH. So this is giving us ethanoic acid. Ethanoic acid. Are you with me? Why the other one is giving us ethanol. But this young man is called ethyl ethanoids. This simply means that the acid hydrolysis of ethyl ethanoids, acid hydrolysis of ethyl ethanoids gives us what? Ethanoic acid and what? Ethanol. That's what I said. Acid hydrolysis of alkanoids will give us an alkanoic acid and alkanol. If you're using ethyl ethanoids, you give us ethanoic acid and ethanol. Does that make sense to you? But now let's show alkaline hydrolysis. We have CH3, COO, C2H5. We are using sodium hydroxide. This reaction is not reversible. That's why we are using one arrow now. One arrow, not reversible. The sodium will combine with this. You see that? That is, we form a salt, and that will give us CH3, COO, Na. This is a salt of the carboxylic acid, of the alkanoic acid. And this will remain as C2H5OH. You can put that down. This young man is called sodium ethanoids. Why this one is called ethanol? Are you with me, please? So it's called ethanol. I repeat, this is the acid hydrolysis. The second equation here is the alkaline. This is the acid hydrolysis. This is the alkaline hydrolysis. This is the alkaline hydrolysis. It is giving us a salt of the alkanoic acid. And that salt here is an alkanoate. Yes, of course. This is a salt. A metal is present. Sodium ethanoate. So acid hydrolysis of ethyl ethanoate gives us ethanoic acid and ethanol. But alkaline hydrolysis of ethyl ethanoate gives us sodium ethanoate and what? Ethanol. Very, very important. Very, very important. Now, the last we have in the reaction is what is called ammonolysis. 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 We are using ammonia now to break it down. Yes. And if it's done, a new compound will be formed. Put these points down. When a mixture, okay, I'll put it this way. Put it this way. Ammonolysis of an alkanoate gives an amide. Gives an amide and alkanol. Gives what? Amide and alkanol. Put that point down. Ammonolysis of an alkanoate gives an amide and what? Alkanol. Ammonolysis of alkanoate gives an amide and what? Alkanol. Have you gotten that? This is the way they can put the question. It can come this way. Put this question down. When a mixture of alkanoate and aqueous ammonia, when a mixture of an alkanoate and aqueous ammonia is refluxed, I repeat, when a mixture of an alkanoate and aqueous ammonia is refluxed, Have you seen that? The corresponding amide and alkanol are produced. The corresponding amide and alkanol are produced. All right. Let me show you this. Let me show you this. This is RCOO R prime. What does it represent? RCOO R prime. What does it represent? What does it represent? Alkanoate, right? So this is an alkanoate. Alkanoate. We are now combining with NH3. NH3 is called what? Ammonia. NH3 is called what? Ammonia. Are you with me? Now, in this reaction, look at what will happen. This R will go out with this oxygen. This R prime will go out with this oxygen. And we'll be left with RCO. And in this ammonia, NH3, we're going to remove one hydrogen. One hydrogen will be removed. What we're removing now is one hydrogen. It will go out and wait here. Follow me. What is remaining now? If we remove one hydrogen from this person, what is remaining? NH2, right? That NH2 will be bonded to this. Remember what we remove from here is O and R. It will come here. This young man will go here. So we're going to have ROH. I repeat, RCOO R prime. We're going to remove the R prime and one oxygen. And when you come to the ammonia, we're going to remove one hydrogen. Both of them will join to form ROH. What is left here is RCO. What is left is NH2, an amino group. You join this person. Now, this person formed RCONH2. The group of organic compound represented as RCONH2 is what? Amide. Amide. While ROH is what? Alkanol. Are you with me, please? Which means ammonolysis of an alkanol, of an alkanoate, ammonolysis of an alkanoate will give us amide and alkanol. Or you say, when a mixture of alkanoate and aqueous ammonia is reflux, the corresponding amide and alkanol are produced. Does that make sense to you? Which means if we use ethyl ethanoate now, what are we going to produce? If we use ethyl ethanoate, which is CH3COO C2H5, this is ethyl ethanoate. Ethyl ethanoate. This is ethyl ethanoate. With ammonia now, NH3, it will give us. Now, what I said earlier, this is C2H5. Don't forget C2. Remember, I told you that the R and one oxygen will go out. We are going to remove this. We are left with CH3CO, CH3CO. And NH2 from here we join, right? NH2 from here we join, NH2. Are you with me? So this person is called ethanamide. Ethanamide. And what is the corresponding alkanol form? This is CH2H5 with O plus the one hydrogen coming from here. We're going to have C2H5OH. This is called what? Ethanol. Which means when ethyl ethanoate is, okay, when a mixture of ethyl ethanoate and aqueous ammonia is reflux, it will give us what? Ethanamide and ethanol. It will give us what? Ethanamide. Though some people will say ethanamide. Ethanamide. You are going to form ethanamide and ethanol. You are going to form ethanamide and ethanol. Ethanamide. Ethanamide We are going to form eternamide and ethanol. We are going to form eternamide and ethanol. In this reaction, when we use aqueous ammonia to react with ethanol. Let's proceed, please. Let's proceed. Hey, God. You can go over with it again. Let's convert into song and be happy. Now we have eternamide, eternamide. You are going to form eternamide and ethanol. You are going to form eternamide and ethanol. In this reaction, when you want to use aqueous ammonia to combine with this compound, when you want to use aqueous ammonia to combine with this compound. Oh, let's go to the next thing. That's the singing tutor on the line. Let's proceed. All right. We have looked into the reactions. We made mention of the ammonolysis. We made mention of alkaline hydrolysis. We made mention of what is called acid hydrolysis. So the acid hydrolysis is reversible, whereas the ammonolysis, the alkaline hydrolysis, is irreversible. All right. I would have loved us to look into a series of questions tonight, but hopefully we might do that tomorrow. But before we close, we are going to ask you at least one or two questions before we close. Are you ready? Are you ready? All right. I'm looking for a question that we ask you guys. When should I ask you guys? Which question? Listen to this. Put this question down. When sodium ethanoate have you written that? Is treated with a few drops of concentrated when sodium ethanoate is treated with a few drops of concentrated tetraoxosulfuric acid, a few drops of concentrated tetraoxosulfuric acid. Have you gotten that? One of the products is dash. One of the products is dash. One of the products is dash. What will be the answer? I said when sodium ethanoate is treated with a few drops of concentrated tetraoxosulfuric acid, that is H2SO4. One of the products is what? What will be the products? What will be the products? Should I give you options? Should I give you options? All right. Let me give you options. Option A. In the options here, in your past question, we have option A. We have CH3COOH. Option B. We have CH3COOCH3. Option C. We have CH3COOC2H5. Option D, we have CH3COO and COO and what? And that's CH3. No, sorry, this is C2H5. Sorry, The option D is C2H5, COOCH3. What do you think would be the answer? What do you think would be the answer? What do you think would be the answer? Let me leave so that you can see the options clearly. What do you think would be the answer? What do you think would be the answer? Put it in the comment section. Someone said C. C. Is that the correct answer? Option C. Is that the correct answer? The question says when sodium ethanoate is treated with a few drops of concentrated H2SO4, right? One of these is the product. Is your C the final answer? C is CH3COOC2H5. Okay, A, yeah, I can see that. A, that's the correct answer. To give you ethanoic acid. That is an alkanoate being treated with H2SO4. Okay. Which other question should I ask you? Which other question? Which other question? Next question. Put this question down. An organic acid. Put this question down. An organic acid. An organic acid. Have you seen that? An organic acid with a pleasant smell is likely to have a general formula dash. An organic acid with a pleasant smell is likely to have the general molecular formula dash. Let's put the options on the board here. The general molecular formula dash. What will be the general molecular formula? That's the question. What will be the general molecular formula of that compound? Option A says, option A is CN H2N plus 1 COO CN H2N H2N plus 1. Option B says CN H2N plus 1 CO. Then we have CN H2N plus 1. Okay, let me go this side so you can see what I'm writing. Yeah, you can see that now. Now we have option C here. Option C says CN H2N plus 1 CHO. Option D says CN H2N plus 1 COOH. What is the answer, please? You know, if you not see RCOO prime in the option, you should see CnH2n plus 1, COO, CnH2n plus 1. Is that clear? All right. Next question. Alkaline hydrolysis. Put this question down. Alkaline hydrolysis of natural fat and oil. Alkaline hydrolysis of natural fat and oil gives dash. Option A, fat and acid. Option A, fat and acid. Option A, fat and acid. Option B, soap and glycerol. Option A is fat and acid. Option B, soap and glycerol. Fat and acid. Option B, soap and glycerol. Option C. The option C says margarine and butter. Margarine and butter. And butter. The option D says esters. I repeat, alkaline hydrolysis of Naturally occurring fat and oil yields dash. What will be the answer? What will be the answer? Alkaline hydrolysis. Yeah. Soap and glycerol. Soap and what? Glycerol. That's correct. Next question. Next question. How many questions should I ask you one more time so that we can close? Before we close, how many questions do you want? How many? How many? Someone said 20. You are wicked. Me to remain here. Okay, okay. Let's get this question. Okay. In saponification, put that question down. In saponification, sorting out is done using what? If you know the answer, put in the comment section. In saponification, sorting out is carried out using what? In saponification, sorting out is done using what? What do we use to do sorting out in saponification? Sorting out is done using what? What do we use to do sorting in saponification? Someone says sodium chloride. That's correct. Dilute sodium chloride. All right. Going to come to the end of this live stream. We've spent so much time with you guys. I believe you must have captured a lot. You must have captured a lot. I believe that. We have done a lot under these alkanoates. And we are done with alkanoates. Yes, we are done with alkanoates. 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 If you really enjoyed what we did, please help us to say something in the comment section. Give us a thumbs up. Help us to share this live so that others can utilize the link and learn what you've done so far. And learn what you've done so far. It has not been easy, but I believe you guys achieved something tonight. You guys achieved something tonight. At this point, we are going to stop. Any questions so far? If you have a question, put in the comment section. Let me tackle it before we stop. Any question? Any question? Any questions so far before I stop? Any questions so far before I stop? Someone said, thank you so much for today. I never knew I could watch to the end. Also, thank you guys for believing that you will learn something, for staying to the end. We have our top fans from this chat. We have our top fans from this chat. They will be rewarded. Thank you guys. Enjoy. Have a nice day.